Batik is one of Indonesia's proudest cultural treasures. It was recognized by UNESCO back in 2009. But behind every beautiful batik cloth, there is a hidden problem. It is wastewater. Most small batik business still don't have proper treatment system. Their wastewater is loaded with organic pollutant, suspended solid, and even chromium. These are dangerous substances if they flow straight into our river.
So, how do we fix this? Our research explores a method called electrocoagulation. It uses electricity to trigger chemical reaction in the water. We use iron electrodes, but not the usually flat plates. We design them as a spiral. Why spiral? Because coil shape give a much bigger surface area in a small space. Each electrode has around 80 square centimeter of a contact area. That means more a contact with the wastewater and more pollution being formed without needing a bigger tank.
To find the best setup, we test three key variables step by step. First, the number of electrodes. We tried 2, 3, or 4. Second, the processing time. We tried 30, 45, or 60 minutes. And third, the output voltage. We tried 9, 12, or 15 volts. Before and after each test, we measure COD and TSS levels. COD tells us how much organic pollution is present. TSS tells us how much solid material is suspended in the water.
Here's what we found. With 4 electrodes, COD removal reached almost 89% and TSS removal reached out about 72%. This was the only setup that met the required standard. Next, we look at the processing time. At 45 minutes, COD removal jumped to over 90%, but pushing it further to 60 minutes barely changed anything. This told us the process had basically reached its limit. So 45 minutes was the sweet spot, saving both time and energy.
Now, let's talk about voltage. This part actually surprised us. We expected higher voltage to always mean better results, but at the 15 volt, COD removal actually dropped compared to 12 volt. Too much voltage caused overheating and side reaction that reduced efficiency. The real winner, the 20 volt. It achieved a COD removal of 94.6% and a TSS removal of 81.7%. So, the optimum combination overall was 4 electrodes, 45 minutes, and 20 volt. This combination brought pollution level below the legal discharge limits.
So, what does this mean? Among the three factors, processing time had the biggest influence on result, followed by volts, then electrode number. And here's the business takeaway. A spiral electrode design can achieve excellent pollutant removal without needing lots of electrodes or the Hawk rector. The max is a simple, affordable, and practical solution for small batik industries. Finally, they can treat their wastewater properly and protect our river for the future.